I took this photo of the question mark nebula NGC 7822 from my front yard in Victoria last June in 2024. And the colors in this image, I processed the photo using the 4x palette when the red, green, and blue channels are mapped to different gas emissions. But the main reddish color is the hydrogen that's ionized by the stellar wind from the massive stars. This emission nebula is one of the youngest star-forming regions in our galaxy. Some of the stars here are only a few million years old, and on the cosmic astronomical timescale, this is basically star burst that's happening in front of our eyes. Also, this nebula contains the hottest star found within 1 kiloparsec of our Sun. This is the BD plus 66, 1673. It has a surface temperature of 45,000 Kelvin and the luminosity 100,000 times that of our Sun. This is the enormous star that's responsible for ionizing the gas in this entire region and compressing it by the stellar wind, and that leads to gravitational collapse and formation of the new stars. So as far as photography, I used the refractor telescope. It's a 478 millimeter focal length and fairly fast optics, f5.9. The image was shot with one-shot color OSC camera. It's a full-frame camera that collects red, green, and blue light simultaneously in one shot, kind of sacrificing a little bit of resolution of the mono camera for the speed of data acquisition. So this is a total of about 3.5 hours exposure, then integrated on the computer to pull out the details. And I used the dual narrow band filter, which passes light only in two narrow frequency bands corresponding to the primary colors of the light emitting gases of the nebula. That's very effective for cutting through light pollution and kind of pulling out these details. So although it's technical, it's fairly straightforward way of photographing emission nebula, and very rewarding. It amazes me that it took these photons, this light, to travel 3,000 years before reaching my yard here and being captured.